Hello, party people, and thank you so much for joining us for another exciting installment of the Customer Success Skills Exchange. We have a very special edition today where we'll be doing a technical showcase of GitLab 13.2. So we have the privilege of welcoming Dan Gordon and his team, the technical marketing team, with some special friends. So I will hand it over to Dan to intro and set up the agenda.
Chris. Hi, everyone. I'm Dan Gordon, manage technical marketing team. We are really excited to be able to show you guys what we released in 13.2. It's not just technical marketing team, though. We also have the technical evangelism team. We worked together on presenting some things here. So you guys will meet the folks as we get going, but we're going to cover a series of things. I've told each team they've got 10 minutes, right? Because we got a lot of stuff to cover here, but in a given amount of time. So we're gonna do a little bit of Q&A at the end when we can on the clock. Any other Q&A that we don't have time for, that you do have questions, put them in the doc. And I think, Chris, if we have time at the end, can we also just come back around and come back to the questions that we don't get to? Otherwise, we'll make sure we answer them, asynchronously. So in general, each team's going to cover what is it, why does it matter, how it works, either through a screenshot or through a live demo. There's a learning more slide with links, and then, as I mentioned, a little bit of Q&A if we have time for each group. With that, I'm going to stop sharing. That was all I wanted to share, and turn it over to Tye, who has the first couple. If Tye is on the call.
I'm on the call. I'm always on the call.
Always there. Awesome.
I thought you were sharing. 1 second. I will share.
Yeah, so it's for the team, because we're logistics of this. Since different folks are doing demos, we're going to have each team that goes share their desktop and do their part of the presentation.
All right, my name is Tye Davis. I am part of the team that focuses on manage and plan. I'm going to be talking about just, there's a couple things that came out, more than 2 things that came out for plan, but I'm going to talk about 2 of the top ones. One that has been heavily anticipated for a long time is assigning issues to iterations. So something that has, been a request from a lot of customers, a lot of us internally as well, in order to track based on not just using milestones, where we can only have one specific milestone for an issue, where you can have multiple choices of having maybe a milestone that is let's say a release. Let's use examples like 13.3 for GitLab's releases, but you also have sprints that are within that release, and being able to identify that for the work that's being done around that issue. So assigning issues to iterations. These are right now available only at the group level. They are not at the project level. So at the group level, you can create an iteration. These iterations there can only be one iteration at a time. So your time dates have to be very specific. They cannot overlap. If they do overlap, it will send you an error saying that there's already an iteration that has these dates, and I guess would help with staying in line that that there's nothing that are staggered on top of each other. So why does this matter? This matters because we've seen many requests come from customers where they are deciding against another project management tool that has these things in place. Many of you come from project management tools that long have had this, I'm not going to call it simple, but this ability to identify sprints and releases and group that together with the issues that you're working on. These are just a few of the quotes that we've seen in the issue that's open to the public that's being worked on. And so from an Agile perspective, this will help teams better coordinate efforts if they're doing Scrum, if they're having sprints that are part of that Scrum. In the long run, we'll be able to have metrics around those iterations, or if they're using them as sprints, you can pull metrics around that specific work being done in those iterations. And that helps teams who are doing, have velocity baked into the work that they're doing, or they are trying to basically look at a team's velocity and measure out the work that can be done within a specific release, which I would have as a milestone, and then the iterations that are part of that release. How it works is, and there's at the end of this, you'll see I've put a little video together, just a how-to video. You can go click on that and watch the video, but I just have screenshots because of time. You can select iterations in groups, create the new iteration. It's going to show, it's very small screenshots, but this was the template. So sprint 1, sprint 2, in this case, I already created 2 sprints as part of that iteration. It's going to create a time box. You choose the dates. Let's say we're doing 2-week sprints. I create that. And this step 2 down here, if I chose a date that overlapped with another iteration or another sprint, it would throw an error, so you can't do that. There's already an iteration that's scheduled for this time. Step 3 is once you begin assigning issues to that, whatever you name that iteration, in this case, sprint 1, it's going to show that percentage complete, how many are open, in progress, and completed. And then this is just a view at step 4 on the right of an issue. You can now see on the right side that there's a milestone and an iteration view. So you can see that this is part of PI1 and sprint 1. Maybe someone's doing safe and they have project increments and sprints within those PIs. This just has a link to the docs, to the epic and the issue that's correlated with it. And then there's a how-to video that I put together on just how to set it up. Something that you guys have already maybe have seen that Gabe put together as well when the release came out. The second thing I'm going to talk about, 6 minutes here, is a Jira issue list in GitLab. This also came out in 13.2. What is Jira issue list in GitLab? You can now view the issues from a project inside of Jira, inside of GitLab, and it's just going to bring you a list view. Now, at this current time, what you're really able to see is just that running list, and it'll pull in the tabs based on if it's open, closed, or in progress. You can, similar to how you are in GitLab where you have all open and closed, if you click on those, all will show all the open and closed Jira issues. Open will show in progress or open, and then closed is going to show all those issues and Jira that are done. That is mostly to the extent of what you can do right now in this MVC. You can create an issue. I guess that's in the screenshots. Create an issue from within GitLab that opens up Jira, but you're going to be creating a Jira issue. Jira is one of the top 3 integrations that are requested by customers. This brings an additional option of having Jira integrated with GitLab, and I'm going to kind of touch on that here, what that really means, because there are multiple options right now of integrating with Jira. This is now another one. How it works is you're going to go to the integration panel on the left, select Jira, just as you would if you were setting up that basic integration. At the very bottom of if you have set up this integration before, you will now see that there's enabled Jira issues, and you need to pull that project key from where it's found inside of Jira. So in this case, I had a mock organization, healthcare provider incorporated, HPI was the key inside of Atlassian. I pulled that, I added that into GitLab, and then it starts that pulling that Jira issue list in. On the left, you'll see in the left panel that it'll change from just, if you have a basic integration set up with GitLab Jira, it'll now say Jira issues. You can view that list, and then it'll show that list. Like I mentioned a minute ago, you can create a new issue in Jira, which will open up in Jira, and it's not creating an issue in GitLab. And that's important to know that there is a separation there, so you're not going to actually get to create that issue within GitLab. A couple different things, resources, the docs. There's a video on how to set this up as well, the Epic, and then there's also a Epic here that if you can provide feedback, this is something that Gabe created. This is going to get feedback on aligning basically what they've done with the Jira importer, and now where there's this Jira issue list, and these are two things that are being worked on separately, and there's an Epic open to kind of bring the two together, and Gabe would appreciate it, and me as well, if you come on, go to this Epic, read over it, and then provide your feedback as well. Last thing I want to show is just because there's a lot of Jira integration set up, or there's a lot of Jira approaches to integrating GitLab with Jira. You have your basic Jira integration that can be set up, and then you have the additional Jira dev panel that will show your branch, your commit, and your merge request within Jira attached to an issue. There's also a GitLab for Jira app that is cloud only for .com to Jira Cloud. This does what basic Jira integration and Jira dev panel do all in one, but it is cloud only. We have Jira import, which is you can import your issues from Jira. This is something that's been a big effort in the last few months. Gabe's leading this, and they continue to roll out new capabilities around that. In 13.2, I didn't touch on it, but you can now map users inside of this Jira import. And then recently is the Jira issue list, which is still separate at this time from Jira import. That is it for me. Any questions, I guess?
There's a few questions in the, you got time.
Yeah.
We'll get to those questions towards the end.
Do you want to do the questions at the end, Dan, or do you want to do them now?
Yeah, let's just to make sure we get everyone else in. Let's hold these questions to the end.
Cool.
We'll come back around to them. So William and Michael.
No, I need to share.
Yeah.
But I will talk.
Yeah.
So hello together. My name is Michael, and I'm a developer evangelist since I'm in my 6th month right now. And we, together with William, we're going to talk about the official GitLab Figma plugin, which was released with 13.2. Next slide, please. What is it? It kind of bridges the gap between designers who want to work on specific designs, specific images, websites, updates, and anything else. And when they want to do sort of a review, they always need to download it from Figma and then upload it again into a GitLab issue to do some reviews or even a merge request. And this is where our design management component or feature comes in. And we wanted to integrate it seamlessly into Figma, which basically means that I don't want to leave the context from Figma and just have the opportunity or the possibility to upload a specific design directly into GitLab, do the review process workflow, and then continue. This is shown in the screenshot and the description. Why does this specifically matter? There's for once, we want to integrate Figma and GitLab even more. And we also don't want to waste too much time with changing the browser tab or changing the applications. It should just work in one go, and the other side can review. For ourselves, it also matters in a way that our design teams and UX teams are using Figma. so we can speed up our own workflows and our own processes. And it also highlights a showcase for GitLab for non-engineering teams, because oftentimes we are talking about GitLab for the DevSecOps lifecycle, and but not really maybe for marketing or for design management. And this opens up more possibilities and opportunities to drive GitLab everywhere. How it works, and this is just a screenshot story. We basically create an issue from Figma in GitLab. So there's a right-click context integration, which requires the plugin to be installed at first, and then there is a pop-up overlay which enables us to search for a specific issue where we want to upload the design, or we might also just paste the URL, and then the context basically goes into the review in GitLab, where it's just like the known merge request review workflow. We can do the design review, add comments, add markers, add pinpoints, say that I want to change specific things, and this can then be like fixed or adopted in Figma, uploading a new design and continuing the whole workflow, getting it approved and merged back to production. But since this is just the static screenshots, we also want to see this live. So William has prepared a nice demo he's going to show you now.
Yes, hello. So this is what more or less what was in the screenshots. I'm gonna show live. So like everything, we start with an issue. So let's imagine that I am a designer that I was assigned an issue in which I am required to upload a design. So having this issue existing here and the plugin from Figma, what I can do is just right click, and here in the plugins, I will see GitLab. And if I just right click in upload designs to GitLab, I will see, for example, that the issues that were assigned to me, I can see them from here, from this view. So in this case, this was the issue that was previously created here and assigned to me, and I am the designer. So now I can just select this one and upload it. So in this case, this is the magic of the plugin, because what we are doing here is that there is a previous integration that is provided by this plugin. And now when I come to the issue, we can see that now it is in GitLab, and I can start collaborating on it. So let's say that I'm gonna switch roles now. So this is what I sent from Figma to GitLab. And if I were the developer, in this case in incognito window, and I say, I don't understand, for example, what type of color is this one? I don't know, a scale of blue, let's say. And then if let's say that I comment on this in a specific part of the design, and as the designer, then I can quickly review this. And if there is, for example, a change that I need to make in the design, I can, sorry.
You need to switch into Figma.
Yeah. So let's say that when I do this, and I can collaborate in here, and if I am asked to, let's say, change this color to another blue or orange, just as an example, the way in which I can do this is that I get the feedback from GitLab side, and I can just quickly come here. Let's say that I change the color in this view from Figma, and once I'm happy with my changes, I can just redo again the plugin and upload the designs. I select the issue. Sorry, I select the issue that we were working. And once I'm done and the design was uploaded, this is where we will start having here that there will be a version control, and I will be able to see that there are different versions. So as if you remember, if you recall, there was one with a blue button, and now the latest was with this change that I just made with the orange one. So what we are doing here is that the designers are first-class citizens in GitLab, that we are fostering collaboration in which you can interact, developer, designer, collect feedback here. You can resolve the threads, have conversations around designs, and speed up any development that requires input from someone that is creating a design to a developer, for example, that is implementing this design. So more information about it, there is an official page in which it explains how to install it. It's very easy. Click on plugins, and if you don't have it installed, this will be blue, and then you click on install, and that's all that you need to do. Right, so questions at the end, or?
We have a couple of minutes left. We could do some Q&A.
Okay,
Yeah, my
so,
question, William, was around
what's one in there, yeah.
configuration of the plugin. How does it handle like multi-factor authentication and all that kind of fun stuff?
okay, in this case, what it's available today is that you have to create an API token in the settings of GitLab, and then you register this token in Figma. So the typical that we do here, that you go to your settings, and there will be somewhere here, or you have access tokens. For example, I created this one here, and then at some point somewhere here that I can't recall now, I will come back to you with this. There is a place, it's because I already have it installed. When you are installing the plugin, it will pop up asking you for this personal token. So this personal token will enable this integration. Therefore, when you have the issues assigned to your user, then you can find those issues from here when you click here. And all of this comes through this integration.
Cool, thank you.
Mm-hmm. All right, so.
Questions, we can move on. Did you have, there's also a resources page as well with some pointers to things.
Yes, so if you want to learn more, we also added some resources pages where you can go to the repository, the issue, and you can add your feedback, and you can learn more about this. This is a beta version that was released for this version, so you can learn more from here. All right, thank you. So
it's a
I will stop sharing.
Hi, I'm Itzik Gan-Baruch, and today I will speak about dynamically generate child pipeline configuration with the Jsonnet. This is part of the CI use case go-to-market, and this is something that also released in 13.2. So what it is, so it's very simple. It's just in 13.2, they just released a project template as just an example of how to use a Jsonnet, and I will elaborate what is Jsonnet. And a little bit context, it starts from the multi-project pipeline or cross-project pipeline that released maybe 1.5 years ago, which allows you to trigger from one pipeline, you can trigger a cross-project pipeline to call to a pipeline in another project via a bridge job. And you are in your project, and in your pipeline graph, it looks like when you call to a cross-project pipeline, in your pipeline graph, you will see the downstream pipeline. Although it's running all of the jobs in other pipeline, it will look like it's the same pipeline. So this was released 1.5 years ago, and it was called the multi-child pipeline. And 12.7, we released the parent-child pipeline, which is again a way to form a pipeline to invoke another pipeline, but the parent-child pipeline is more to invoke pipeline in your project, not in a cross project. And for that, you needed to trigger, there is a bridge job, and you need to include a path. In your repository, you have subfolders. For each child pipeline, you need another YAML file. So in advance, you create those subfolders in the YAML files. And 12.9 released the dynamic child pipelines, which is another iteration on that, which you don't need to, in advance, create those YAMLs. You can, at runtime, with a script, generate the YAMLs for the child pipelines. And you can call trigger pipeline. Now you don't need to include path. You can include artifact. So this is the new thing that released on 12.9. The challenge with that, or the difficulty with that, is that you need to write your own script in order to generate the pipeline itself, which is possible, but it's not so easy. So in 13.2, there is a project template to use Jsonnet, which is a data template open source by Google. That with that we can generate the pipeline. It include logic, loops, iterations, and things that help you to develop. I can see this. Okay, so this is what released on 13.2 is just an example. So why does it matter to generate a pipeline at one time and parent-child pipeline? So first of all, for monorepos, large repos which monorepos become very popular recently. And in monorepos, it's avoid long and complex pipeline. You have for each module, you have its own pipeline and one parent pipeline for the entire project. But this way, it's much more easy to manage and debug. The second use case is to generate pipelines for targeting content that changes. It is unknown during build time. For example, if you're building a software for hardware, and you have many targets like debug, release, and you have also different architectures. And you may not want to create jobs for these targets, or sometimes it's not known which environment is available and what was changed. So during that runtime, you discover what needed, and then you generate a pipeline for the targets that are needed. Another great use case is to build a matrix of target, or as we call the build matrix. And for that, I will have, you can implement a matrix build, and I will have a demo, live demo for that. And the last reason for that is to reduce boilerplate and repetition by letting you write script that generates YAML instead of hand typing it at all. So how it works, how you make that? 2 steps. First, you need to create a Jsonnet script, and the script dynamically generate the YAML, and you add logic loops as you want to the script. The second thing is in the parent pipeline, you add 2 jobs. One job that called this Jsonnet script, and the script will generate the pipeline, and then you store it as an artifact. And the second job is a trigger job or a bridge job that will take this YAML from the artifact and trigger the child pipeline. So I use this capability, and now I want to show you a demo how I can create build matrix with Jsonnet. So this is GitLab. Okay, so I will start from, this is my project, and I will start from the YAML file. And I have here 2 jobs. This is the first job, Jsonnet, I call it, and it used the Alpine image. And in the script, we download Jsonnet, And then when we have the Jsonnet, we call the Jsonnet script that I created, I will show you. And the output of running of this Jsonnet, it will generate this YAML, and I will store it in the artifact. The second job is the trigger job, and it will just trigger it. It will take it from the artifact and run it. So let's see what is the Jsonnet script. It's short as well. So I added here 3 arrays, one for the different targets environments. I have Windows, Mac, Android, and iOS. And I want to test them for, in this example, in Chrome, Safari, and Firefox. And I have also 3 different architectures. So I have here a 3-dimension array, and I want to test all of my application with all of those combinations. It's like 4 on 3 on 3. It's like 36, if I'm not wrong, jobs I want to create. So instead of writing all of the 36 jobs, I wrote this 3-dimension loop that it will run and create a job for me. And this will be the job name, and it will call this function with the parameters, and the function will create a job. And each job will do the same. We'll use this image, we'll run this script. So it's very simple. And now I will show you how it looks like. So I will run the pipeline. Okay, succeeded, and immediately we'll see here, should see here the artifact, and I will just download the artifact, which is the YAML. And this is the YAML that it's created for me. And this is all of the jobs that it created for each combination: Android with Chrome A, Android Chrome B, Android Chrome C, Android Firefox A, B, C. So I have here, it helped me to generate all of this. And of course, now if I go back to the pipeline, it also ran it. So I go back to the pipeline. And this is the trigger job. And this is the downstream project, the child pipeline. If I click on that, I will see all of my jobs. So this is it, how you can implement build matrix for complex environments that you have to test. You don't no more need to write everything in the YAML. You can have a script, Jsonnet script, or other language. There are other languages like Jsonnet that you can use to create on runtime your YAML. So going back to the slides, and if you want some resources, here are the resources and questions. So if not, I will.
Hey,
Looks like
Itzik, I have a quick
more.
question. Oh, sorry. Go ahead, John.
Yeah.
No, that was for you. Go ahead, Steve.
Oh, it's just so I understand, you were importing the Jsonnet itself in the job, so there really isn't any GitLab functionality to support Jsonnet. It's just sort of an example of how you can template the creation of a YAML, right? Or is there some GitLab functionality that supports it?
No, you're right, totally right. The Jsonnet is just, there is no any relationship between GitLab and Jsonnet. It's just an example. And as I said, there is other languages like similar to Jsonnet and that you can use. The only relation is that now out of the box, we have a project template that uses Jsonnet out of the box. So if you go,
oh, great.
Yeah, so if I go here to let me show you this template. But as I said, it's not, you see Jsonnet for dynamic pipeline, and let's do preview. It's similar to but it's very simple. this is the template that exists. It just create 2 jobs. I added some logic to implement the build matrix. But again, it's the only thing that GitLab brings here is the way to trigger a child pipeline with an artifact,
Right.
versus
Yep.
what was before that you needed to define a path for the artifact. So this is the new thing, which is powerful because now you can, or if you want to write your own script, or you want to use languages like Jsonnet. Right?
Terrific. Thank you. Yeah, that's extraordinary. That's awesome.
Yeah, thanks.
Thanks, guys. In the interest of time, any other questions we'll get to at the end or offline. I'm going to move on to Fern with container host monitoring. Thank you, Itzik.
Oh, sorry. Oh.
Hey, how's it going, everyone? So I'm Fern from Technical Marketing. So I've been in this presentation before, and today I'm going to go over container host monitoring and blocking. So let me go share my screen. Right. Can you see can everyone see my browser?
Yep.
Okay, perfect. All right, so let me present. And okay. I don't know what's going on there, but okay, so just to give a little bit of information on container host monitoring and blocking, there's 2 tools that we use for this. We use Falco and we use AppArmor. Falco is for monitoring and AppArmor is for blocking. And essentially what these tools do is they monitor the Linux kernel and look for certain system calls, and then they assert those calls against the rules engine. And if those calls meet the rules, then we can go ahead and send different alerts to different applications and different endpoints. And what this does is it helps us add any additional logic to be able to handle whenever an event has occurred. So pretty much what it will do is it'll send alerts to standard out or to a file where we can have a custom application monitoring that, and then we can go ahead and take an action. So this helps find any malicious activity within a system, and then lets us, maybe we want to monitor it, and maybe we don't want to act on it right away because it could be either an internal process that we just need to look at and see if someone's doing something internally that's not malicious, or we don't want the hacker to know per se that we know that they're intruding because we want to take some effective action, or we want to be able to take an action like block or switch or drop a load of a workload and then switch it over to another workload that's unaffected. So there's a lot of reasons to use this. And then there's blocking, which we're still monitoring containers for different system calls. For example, writing a file or accessing the network, and we can block that process from taking effect. So essentially the user will get a permission denied. And then number 2, we can implement that in a pod security policy where pods won't even be able to run on the system if they're performing a certain system call. So those are the benefits of container host and monitoring and blocking. So let me show you a few examples here. So I put together, this is a sample rule within Falco. And what this rule does is if it detects bash being run within a container, it'll output shell spawned in a container other than entry point. So it'll show you that someone is in a container and they're running a shell script, meaning that this is something that shouldn't be done, within our security policy, and we're going to go ahead and alert on that. And then what we do is we alert to standard out or a file or syslog, or we can even send a request to an endpoint. And then from there, we can act and we can perform whatever it is that we need to. And these rules can be configured in many ways, and there's just many different rules for exactly what's going on within a container. The second example that I'm going to show you is host blocking. So what we do here is we create a profile within AppArmor, and I'm going to show you how this is done after showing this. But what you do essentially is create a profile using AppArmor rules, and this profile is going to say that we're going to deny any file rights within the containers. So we created a profile that says, hey, anytime a file write is being done in a container, let's go ahead and block that and not allow that. So instead of the actual file being written, you'll get a permission denied error when trying to execute a write command on a container. So this is how you would deploy the actual pod. It can be done in a deployment typically. This is just a simple pod creation where it creates a pod and then it runs hello AppArmor. It just runs a command and then we'll create that pod. Now this image that didn't show was just an image of a pod, but I don't know why slides is acting up. So once that's created and assigned the AppArmor profile that we created up here, what it'll do is anytime we try to create a file or write within the pod, we'll get a permission denied error telling us that there was an error writing to the container. So those are the two. That's host blocking. So why does any of this even matter? So there's a few reasons why it matters to customers, and the reasons are that they can take action on any possible malicious activity within their system, or maybe it's something that users are doing and they can go ahead and change their security policy to suit their needs. They can see like, hey, all these permissions are commonly being run. Maybe we should, expect this and lax our security policy, or these things are never really being run. We're alerting on it. Maybe we should, make our policies more secure. So you can do many different things with this. I mean, one example could be getting a count of what activities are being performed on the system to see if they're crucial. That way they can lower permissions and do and make sure that the minimum permissions are assigned to different pods, and a lot of analysis can be done, or there can be action being done. Security teams can be alerted. There's lots of possibilities for using container host monitoring. Container host blocking, you can block processes and prevent intrusion and malicious activity within the containers. So if you want, that something's really bad and our security policy says, hey, this container is a critical application container and there shouldn't be any developers directly accessing this production environment, then through Bash, they should be accessing it through an external source. So then what will happen there is that we can limit that and we can prevent that from happening. And then how does GitLab, and these are just tools that someone can just, they're open source tools, Falco and AppArmor, that anyone can implement. But the thing is that they're not easy to implement into your system. It takes some time to add them to your deployment. And what GitLab does is it makes it easy. You just add the deployments to a YAML file, and then it'll go ahead and deploy AppArmor, it'll deploy Falco, it'll deploy all the rules that you need, and they can just be added and automated through GitLab's built-in Helm charts and just adding a values.yaml, which I'll show you. And how is this good for GitLab itself? Well, it shows that we have a diverse set of security tools and we keep making it easier and easier for our customers to use. So there's some resources here. There's a lot of different stuff I've added on how to actually deploy this yourself. I've deployed this within the Simply Simple Notes demo application, which I'll show you. And I've added information about pod security policies and AppArmor profiles. Pod security policies were not even letting the pod run on a system if certain criteria is not met. So you can go and look at that. I don't have time to show that in depth, but I've left some resources there for y'all to look at after the session. And just to show you how easy it is to add these tools within the GitLab managed apps. you add to the config.yaml, you can add Cilium, you can add, well, that's container host security. You can add Falco, and you can add AppArmor easily. So you can just have installed equal to true, and that'll go ahead and deploy those two applications into your system. Then if you want to configure them, for example, you want to add rules to AppArmor, you can go ahead and add a profile, and each has its specific syntax. This is just Helm values. So there's specific syntax to each one. So you will have to dig in and see exactly how you want to set up your system. But this is an example of denying file rights. So it'll create a profile named profile1 and not allow file rights within the container system. So, and that's as simple as it is. And if you want to apply it to your pods when they're deployed, what you can do is you can edit your Helm template, and then all you need to do is add this annotation saying that any pod named hello, which this is, or any container named hello, this is a container named hello, it's going to run with profile1, meaning it's not going to allow any file rights on the system. And if you look at a pipeline, it'll run the apply job, which will create the infrastructure. And then I also have the deploy staging job, which deploys everything within a staging environment. So the apply job is easily set as a template, and that's all you need to do. You just need to apply that, and it'll go ahead and apply all your applications that you set within GitLab managed applications. And then the last thing to consider would be going to operations, Kubernetes, and then making sure that your cluster is set as a cluster management project. So you can go ahead and look at simple notes and see how it's configured, and then play around with it yourself. And if you want another session that goes into live demo examples and showcases these features live, I'd be happy to do that. Just for the sake of time, yeah, that's where it is, and I'd be happy to answer any questions.
Thanks, Fern. In the interest of time, I think we'll roll questions to asynchronous, and we've got, I know that this meeting typically goes to 50. We've got one more 10-minute stint if you guys can hang on. Otherwise, it'll be in the recording. So I'm going to hand it over to Cesar.
Can you guys hear me okay?
Yes.
Yeah, okay, good. Thank you. Can you see my screen? It should say multiple Terraform plans supporting merge requests.
Yes.
Okay, good. Excellent. So my name is Cesar Saavedra. I'm a technical manager, and I cover CD and GitOps, go-to-market use cases. So I'm going to be covering this feature and another one called read-only access to Terraform state APIs. As mentioned before by my teammates, this is what I'll cover. But first, I'd like to give you some context. So GitOps takes DevOps best practices used for application development and applies them to infrastructure automation. GitOps is one of our go-to-market use cases, and we partner with HashiCorp for some of our GitOps features. Terraform is an open source infrastructure as code software tool created by HashiCorp, and it enables users to define and provision infrastructure using a declarative configuration language. Expected infrastructure changes are summarized by the command Terraform plan, which is used to create an execution plan, which determines what actions are necessary to achieve a desired state specified in the configuration files. This command is a convenient way to check whether the execution plan for a set of changes matches your expectations. And this is, you're supposed to run Terraform plan before committing any changes to version control. So in our case, a merge request is the place to run the Terraform plan command. So before 13.2, only the plan output for a single environment could be displayed as an artifact in an MR. Sorry, was there a question? Or? Okay. So with that context, I should actually, what I should do is I should do like this, present. So with 13.2, the MR widget now supports multiple Terraform artifacts files for multiple environments. So that's what's new. As you can see, this is a screen snapshot of the portion of the MR that lists all of the Terraform plan outputs or the execution plans. In this case, there are 3 of them that have been executed as part of this pipeline. So why does it matter for customers and prospects? Customers, when they're managing infrastructure as code, usually they have many environments, staging, production, for example. With this new feature, they can now review what infrastructure changes will take place across multiple environments in a merge request. And obviously, this will lower the risk of introducing erroneous infrastructure configurations into production, diminishing risk and eliminating unexpected downtimes. What's in it for us? This new feature helps us to better position our integration points with Terraform. It also enriches our infrastructure as code story, and it provides us with an entry point into Terraform accounts. So let's go to the demo real quick. I have 6 minutes. So I've put together a project. I've provided a link to this project in the presentation, so you have access to it, and I've documented it. With the variables that you need to define, in order to be able to execute this project. Basically, just quickly, this project contains a directory per environment. In this case, the assumption is there is a staging environment, there's a review environment, there's a production environment. They all leverage, there's a modules directory, which contains the configuration files for the infrastructure that are reused by each of these environments. So basically, the production environment is doing an include, like in a parent-child relationship from the modules. Same thing with review and staging. And then the pipeline drives basically the application of all the different Terraform commands from Terraform init, Terraform validate, and Terraform plan. And then the last job or stage is the one that allows you to deploy to Amazon. And you get to deploy an instance per environment. So let's see, quickly to get this working within this environment, we can quickly just create an issue. So we'll just call this debug statements from, let's just call it that. And then we're going to, I'll assign that to myself. And then we'll go into that issue. We'll create the MR. And then we'll go into the IDE. And what we'll do is we'll just add some debug statements. And the reason that I'm doing this is just so that we can kick off the pipeline, and then I can show you the execution of it. So let's go to the Terraform apply. Job, which is right here. And we can just put it in the before script here. There we go. There, and then we just commit to that branch. And this is gonna kick off a pipeline. And this is the pipeline that you saw earlier in the file, GitLab CI YAML file. There's the prepare jobs, the validate jobs, and the build jobs. This is going to take a few minutes, so let's just go to a completed one. So this is already a completed one, and as you can tell, 3 production plans or 3 Terraform plans were executed, each one per environment. And if we go to the MR, you can actually see here the Terraform reports. Again, 1 per environment, 1 for production, 1 for staging, and 1 for review that doesn't have a name. So for example, if we want to see the production one, you go there, and this is basically the plan, the execution plan, the output of the Terraform plan command. Okay. So I got 2 minutes left, so I'll jump into the next okay, so I put some slides here with the steps that I just showed you. Once the pipeline completes, you will get the last stage to actually deploy, do the Terraform apply and deploy the instantiate the machines on EC2. For learning more about this, here's the link that this demo project. Here's a link to the project you just saw. There's also 3 other projects that I found that were very interesting, and I'm sharing the links to them here. They provide different scenarios for different combinations of how to run Terraform plans and how to organize your directories. And also there's an interesting epic here if you want to provide feedback for this feature, you can provide it through via this epic here. The second one is read-only access to Terraform State API. Before the latest release, you could not execute Terraform plans if you did not have maintainer access to the project. Sorry about that. So in this release, now you need to, if you're a developer, you actually have read-only access to the Terraform State API, which allows you to run the Terraform plans as a developer. So what does it matter for customers? Developers are able to run our Terraform plan to see infrastructure configuration changes, and developers or GitOps stakeholders can effectively collaborate on infrastructure configuration updates. And for us, again, like before, it enriches our infrastructure as code story, and it enhances our GitOps positioning of taking DevOps best practices to infrastructure automation. I provided the steps to exercise this feature. You need to create a developer branch. You need to add someone with a developer role into the project. Obviously log in as a developer, and then run the pipeline that you just saw from the same project, but specifying that branch, the developer branch. And here are some, if you want to learn more, here are some links for you to learn more about the specific feature. And I can't believe it's 3 o'clock. Good. Thank you. That's all I had.
Thanks, Cesar. We'll take a look at any questions in the doc and answer those offline. Thank you, everyone, for the content. Thank you, everyone, for hanging out and listening.
Thank you, everyone. We'll see you all next week.
Bye.